In this example, we're given that alpha is an acute angle and that sine alpha is 3/5, and we're asked to find the value of cos alpha. The way we're going to do this is by finding the value of cos alpha directly without first finding alpha. Now in some questions, like this one, you could technically do inverse sine of 3/5 and then do cos of the answer, and your calculator would be able to give you the value. But as you'll see in some later examples, that won't always work. So we're going to start by drawing a right-angled triangle. And we'll label the angle alpha. We're told that sine alpha is 3/5. And we know the trig ratio for sine alpha is opposite over hypotenuse. So we can label the opposite side as 3 and the hypotenuse as 5. Then we can use Pythagoras to find the third side. So 5 squared is 25, subtract 3 squared gives us 16, and the square root of 16 is 4. When we have a right angled triangle where all 3 sides are integers, we call this a Pythagorean triple, and these come up quite frequently in trig, and it's worth knowing them because it allows you to sometimes take shortcuts. So let's find the value of cos alpha. We know the ratio for cos is adjacent over hypotenuse, so we know our answer will contain 4/5. But we have to be careful here because sometimes there's more to it than that. When we're drawing this triangle here with our trig ratios, what we're actually doing is finding the magnitude of cos alpha. So we know the magnitude of cos alpha is 4/5, but we also need to check if it has the correct sign. And to do that, we're going to sketch the graph of cos x between 0 and 360. Notice that in the acute region of this graph, between 0 and 90, the graph is always positive. And that means if we know alpha is acute and we're trying to find cos alpha, then cos alpha is 4/5 and not negative 4/5. And so our answer remains unchanged. So in summary, when you're doing one of these questions, here are the 2 steps that you need to go through. Number 1, we use a right angled triangle to find the magnitude of sine, cos or tan. And then number 2, we sketch a graph to check the sign. If you follow those steps, you'll probably find most of these questions quite straightforward. Okay, here's a question for you to have a go at for yourself then. Pause the video and then come back and check your solution against mine. Welcome back, here's my solution. If you didn't get it correct, I'm going to go through how I got it now. So once again, we'll start by drawing a right angled triangle. We know the value of cos beta is 12/13, so the adjacent is 12 and the hypotenuse is 13. We can then use Pythagoras to find the third side. 13 squared is 169 minus 12 squared, which is 144, leaves us with 25, which if we square root gives 5. So this is another example of a common Pythagorean triple that you'll see occurring. Next up, we'll find the magnitude of tan beta. We know the trig ratio for tan is opposite over adjacent, so we get 5/12. As in the last example, we'll check the sign by sketching the graph. For the region that we're interested in, which is the acute region between 0 and 90, the graph of tan is always positive. And so our answer stays as tan beta equals 5/12.